Hello there, today we'll be doing valid Sudoku. This is going to be our 7th problem, and we'll be going over the arrays and hashing that we need to make sure this problem goes well. So in this particular problem, we need to make sure that all the rows and all the columns have unique numbers, as well as each square. The way we can do this is to define each row and create a set at each particular row and create a set at each particular column. We can also create a set at each particular square. The square, by definition, is within this box, which is going to be our 0 box, and this is going to be our 0 1 box, 0 2 box. This is going to be a 1 0 box, a 1 box, and 1 2 box. This is going to be a 2 0 box, a 2 1 box, and a 2 2 box. The way we're going to do that is make sure that all the items in this row and column falls into this box. And the way we can do that is divide the number by 3 and ground divide it. If it's divisible by 3, if it's under 3, then it's going to be 0, which is here. If it is over 3, but under 6, then it's going to be here in the second, and so on and so forth. Alright, I think we can get to it. Let's check out what we're gonna do. So we set rows be equal to default dictionary of sets, columns equals default dictionary of sets, and we can also set squares to be equal to default dictionary of sets. So one thing we can do to reduce the number of rows that we need is rows of code is this. We just copy and paste this over here, and now we have 3. Okay, next step. What we're gonna do is go over every single item in this just Sudoku puzzle, and we're gonna do board in range 9 and for C in range 9. So we're gonna go through every single item, and for each item we're gonna make sure num equals board of R and C. So if num is an equal to a dot, we can just continue because there's no problem there. We're not gonna add a number to our squares. Otherwise, there is a base case. If a number is seen in rows, we can return false. Elif number in columns, we can return false. And elif num in squares, we can return false. So one thing you might notice is that these 3 statements return false, so we can just sum them up into a single statement. Another thing you might notice is that you're asking which column and which row. Well, we're looking at this particular row, this particular column, and this particular square. And with that, we can return false. Okay, so those are our 2 base cases. Now, we can just add all the numbers into our sets to make sure we don't add them in again. And with that, we are good to go. and if we ever see anything that we've seen before in these particular sets, then we return false, otherwise we return true. Alright, very good. Okay, not bad. So this was a pretty nice solution. It went by pretty quickly. It wasn't my fastest solution. Of course, that required a lot more code, but we're trying to go through the concepts here and look at the way we can think about this problem. It's less about the fastest way, it's more about the concepts in this particular series. And the concepts here are seen. We needed sets, we have those. We needed multiple sets, we use dictionaries. We needed to categorize them in specific spots. We put them into rows, columns, and squares. And that way we were able to, create sets where we could identify them by the set and make sure that the numbers are within the row, within the column, and within the square. And if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.